These are the notes for section 2.1, in which we're talking about solving simple equations and using these simple equations to solve application problems, all right? And so here we got an example where we want to determine the size of a car's engine. Now, a car's engine has some cylinders like this here, and these cylinders here fill up with gas vapor, and that gas vapor is ignited, and that's what makes the engine go when it explodes. Okay, so the thing that determines the size of a car's engine is the amount of displacement that these cylinders have. So if they got a lot of volume, then we got a bigger engine, and it can have more horsepower. So here's a formula that determines that, and we've got D equals pi times B squared times SC all over 4. And this is what that means. Here's kind of the description. D is the engine displacement, measured in cubic centimeters. B is the bore, which is just the diameter of the cylinder. S is the stroke, which is measured in centimeters. That's how far it travels. And C is the number of cylinders in the engine. Okay, so we're going to use that now to solve a problem. Okay, so here's the question. Now, all that stuff was just background, which makes it a little easier to be successful at this. So we have this equation I'm going to copy down. D equals pi B squared times SC all over 4. Okay, and so now let's go through this. We know we want to find the stroke that's necessary. So we want to find S, that's what we're looking for a 6-cylinder, what's that? Well, that's C. C is the cylinders engine with a 4.8 centimeter bore. So that is our variable B with a 542 cubic centimeters of displacement. So that's going to be our capital D. All right, so it's a good idea to label these variables like I just did there, right on the problem. Then you're sure you'll get the numbers in the right spot. So all we're going to do now is substitute. Let's put 542 for D, and we'll fill in the rest. And so we fill in all the numbers, and we see that we have all the letters substituted for except for S. Got to be careful, that's not a 5, that's an S right there for the stroke that we're looking for, all right? So now we got to solve up this equation. We can do this a couple ways. One way might be good to just go ahead and multiply these numbers on top here, pi times 4.8 squared times 6. You can use your calculator for that. And when we do, we get 434.2938, rounded off a little bit. Make sure you use the pi key for pi. Don't use 3.14. That's not quite accurate enough, all right? So use the pi key. And in the end, we want to round this to 1 decimal place. So notice I kept 3 or 4 decimal places. It doesn't hurt to write down too much. But if you round this off too early, too much too early, then your answer will get farther off, okay? Got to get rid of the 4. We have divided by 4, so we got to multiply both sides by 4 to get rid of that. So let's multiply both sides by 4. Multiplying by 4 there, we'll cancel out that 4 down on the bottom, and we get 2168 equals 434.2938 times S. So it's multiplying, so we just got to divide this whole thing by that 434 number. So dividing by that 434.2938, we get 4.992. Now we're going to cut it off at 1 decimal place. We want to round it off here. And so we have 9 that's going to bump up, or if you want to think of this like a 49, since this is number that we're cutting off is greater than 5, we're going to bump this up 1. So it's going to, 49 is going to become 50, or actually 5.0 equals S. Let's get our units. That is the stroke, which is measured in centimeters right there, okay? So get our units, that is centimeters. And there's our answer, okay? So that's how we do a problem like that. Now I want you to go ahead and go to your book, pause the video, go try section 2.1, number 12, in your book. And then after you've done number 12, come on back and watch the next example there. In this next example, we're going to talk about the deflection of a beam. We've got a big wooden beam that's going to span across a certain length. And when we put weight on that beam, well, it's going to sag a little bit in the middle. That amount of sag there is called the deflection, all right? And so we want to figure out the distance in the middle of the beam that it drops. All right, so here's our formula. D equals PL to the third power all over 48E times I. And here's what all the variables mean. D is the deflection, how far it drops. P is the weight in pounds that we're going to put on the middle of this. L is the length of the beam in inches. E is the elasticity of the beam, measured in pounds per square inch, all right? And I is called the moment of inertia of the beam, measured in inches to the fourth power. Okay, so lots of things you may be familiar with or not, but don't stress too much if you're not familiar. Just kind of a good experience to learn and know a little bit about this here. So those are what they mean there. Here are the variables we're given. We want to find the moment of inertia. So we're looking for I, which is right down there at the bottom. And we want to find it the nearest whole number. So we're going to plug these in and solve for I. So a good place to start is to copy the formula down here. Now we're going to substitute. We know that D is 1. We know that P is 3250. We know that L is 156 to the third power all over 48 times E, which is a pretty large number here, 1950123 times I, which we don't know. That's what we're looking for is I, all right? So here we've got an interesting situation. We've got a fraction on this side and no fraction on that side, okay? So we can do this, think of it a couple ways. We need to get rid of the fraction. That's the big idea there. So to do that, you might think of this as a proportion. Put it 1 over 1. And when we've got a proportion, we cross multiply. Now, so let's go ahead and multiply these out and cross multiply, or really what we're just doing is we're just multiplying both sides by whatever's on the bottom. We're going to do things a little differently than we did there in that last one, because when you multiply this number, you get a large number that's in scientific notation. So let's just leave this alone for right now, and let's see if we can get the numbers all squared away and then do our calculations, okay? We know that 48 times 1,950,000 is just a number, so let's just leave it alone, okay? When we cross multiply, we're going to get 1 times this, which is obviously exactly what it is, and 1 times that. So we have 48 times 1,950,000 I equals that 3250 times 156 cubed. Okay? Again, we haven't done that multiplication yet. I just know that's a big number, and that's another big number. Okay? So what we need to do now is we need to get rid of this. So let's divide both sides by that number because it's multiplied by I. 48 times 1,950,000, 1,950,000. Divide both sides by that. Okay. And now this is going to give us I on the left side. That's all that's going to be left because these guys cancel. And then we've got whatever this works out to be here. Okay, so let's go ahead and put this in our calculator. Now, when you put this in your calculator, you need to put this whole thing in parentheses and then do divided by this whole thing down here. And it's probably best in your scientific calculator just to write that out there and see what you get. So entering this into our calculator, again, you got to put some parentheses, divided by parentheses. This is all the numerator, this is all the denominator, and in your scientific calculator, you can just multiply that out, and you'll get 131.82. And we got to find our units for that there. Our units up here are inches to the fourth. You don't necessarily need to know why it's inches to the fourth. And I know that's kind of a weird unit, but that's what it means. And by the way, this fourth power does not affect that number. Don't go raising this to the fourth power. That's not what we're saying. We're saying that that is the whole answer there. Okay, the units are to the fourth power. All right, so that's the idea. That's how we work with these equations that we have, fractions. Okay, we got fractions, denominators there. You kind of do this cross multiplying idea. All right, so go try 2.1, number 13, and do that in your book, and then come back and watch the next example. All right, in this example here, we're going to take a look at a wire. We've got a wire that is a certain size. We measure the size of an electrical wire, like an extension cord. We measure it in gauge. It has a certain gauge, and the abbreviation for that is AWG. I don't know, American weight gauge. I don't know what it means. You can look it up. No. Anyways, this is the abbreviation for gauge. So the gauge is the size of the wire, and the size of the wire determines how much resistance we have. So this little chart here is going to tell us the amount of resistance we have based on the size of the wire, okay? And a wire, as this gauge gets bigger, then the resistance gets less, all right? So smaller gauge, larger resistance here, okay? Anyways, so here's our formula. We're going to have a voltage drop for an electrical wire is V equals 2 LIR divided by 1,000. Voltage drops means if we have a long cable, we're going to lose some volts, some electricity along the way. All right, so V is the voltage drop measured in volts. L is the length of the wire. I is the current measured in amps. And R is the resistance. Okay, so we're going to, here's the question here now. We want to use the table to the right to determine the length of an electrical cord. You will have, if you have a voltage drop of 9 volts, what is that? That's V. In a number 12 gauge. Now, 12 gauge is not really one of our variables, but that gives us a clue. 12 gauge right here tells us that R, the R that we need is 1.932. So we found R. So we have V, we have R, and then it says that we have a cord attached to a heater that's drawing 18 amps. So there is our amps, which is right here. Amps is I. So that's our I value. So let's plug in these values. There's our formula again, and we've got 9 volts. We have L, which we know. Do we know L? We know. No, we don't know L. That's what we're looking for. So L is what we're looking for. We know I is 18. And we know R is 1.932. And that's all over 1,000. All right, so this should be a pretty easy one to solve here. We want to get that 1,000 out of there. In this one, you can go ahead and multiply these out. You got 2 times 18 times 1.932. Those are small numbers. In the last one, we didn't multiply it out because we had these large numbers. And when you have the large numbers, you put them in your calculator. It's more of a pain to rewrite them. But this, we can go ahead and multiply the 2 times the 18 times the 1.932. And we get 69.55. Now we have 2 options. We can multiply both sides by 1,000. Okay. Or we could go ahead and divide these 2 over here. We could divide these numbers. That's another way to go. But anyways, let's multiply by 1,000. And then we need to divide by, we got L times 69.552, so let's divide by that 69.552. And when we divide by 69.552, we get 129.3995. Round out 396. Okay, and so we're going to round that off to the nearest foot. So we're going to cut it to the nearest whole number. We notice that we're cutting off a 3, so we go up to 129. 129 feet. right? Yes. That's how we do that. All right. So go ahead and try 2.1, numbers 10 and 14, and we're going to stop our video there for now. And we got one more example, but we'll look at that one later.